Ionic bonds. Ionic bonds are quite simple to understand. Ionic bonds have very simple properties, and one of the main properties of ionic bonds is simply that we have positives and negatives. This force of attraction between positive and negatives are one of the main core principles of ionic bonds. Well, before we move to ionic bonds, let's describe exactly what a bond is. Well, a bond is pretty much just a very strong force of attraction in chemistry. So, if we have this positive and we have this negative, the strong force of attraction between these is causing a bond to form. So, if we take something, for example, let's take an ionic bond. Let's take lithium, let's take nitrogen, for example, and let's write down their ionic charges. Well, this will be positive 1, and nitrogen would have negative 3. So let's just write this ionic compound. Well, it would be Li 3 and then N. And that would be the ionic compound for this bond. Well, you might be wondering how I got from just having these ionic charges to getting to this final answer. Well, it's quite simple actually. So if we move over to a different page, let's do this question again, but let's do this slowly and step by step. So if we take our idea of positively and negatively charged attraction, so let's talk about exactly how ionic bonds form. Well, ionic bonds are simply just positive and negatives attracting. And inside this positive and negative attracting, we have two main parts. Well, we have the cation, and we have the anion. And the attraction between this anion and the cation is causing oppositely charged ions to basically form a bond. And this bond is creating a compound, which we call a ionic compound, or if it's simply just a metal cation, a non-metal anion, then we'll simply just call it a binary ionic compound. So, if we take an anion, the basic principle it is that it's simply just a negatively charged uh, ion. And with cation, it would be a positively charged ion. And when we look at cations and anions, and we look at how they're forming bonds, we have to also do a net charge. And a net charge is pretty much going to be just the entire compound's overall charge, so either if it's going to be cation or anion, or positive or negative, or zero. And if we're going to create an ionic compound, or a binary ionic compound, or some type of compound, we need to have the net charge of the overall compound to always be zero. The zero is going to make the overall compound balanced with the actual elements itself. So if we have something, let's take a new compound rather than lithium. Let's take something like calcium, for example. So let's write calcium, and let's write the positive 2 because that's the charge on it. And then let's take a different element. Let's take something, example, for phosphorus. And let's write the charge for phosphorus. Well, phosphorus has a charge of negative 3, so this is representing that phosphorus needs to gain 3 electrons to become stable, and calcium needs to lose 2 electrons to become stable. And now that we know the ion charges, we can find out how the bond will be formed. Well, let's do the math currently. As I explained previously, we need to have the net charges 0. So let's do the math. So we have positive 2, and we have plus negative 3. And right now, the overall net charge of this will be negative 1. Well, we see that this is not equal to 0, so it cannot be an ionic compound right now at this point. Even though it has a cation and anion, it could be. It's still not going to be a perfected compound, as the net charge is not 0 and it's not creating a strong enough force of attraction. So if we get rid of, let's get rid of these ions, and let's take, for example, well, we know that phosphorus has a charge of negative 3, and we know that calcium has a charge of positive 2. Let's create a common denominator between these. So what do we 3 and 2 have a common denominator? Well, they both have 6. So let's do 2 times something equals to 6. So we have 2 multiplied by question mark equals to 6. Well, that's going to be 3. So we'll do this as 3 as question mark. And then for phosphorus, it'll be 3 multiplied by something equals to 6. Well, this is going to be simply 2. So let's write 2 here. And now let's do the math. So now we have 6 on each side. So this would have 6 now, and this would have 6. So we'd have 6 plus -6, and now we have the overall charge as 0. Well, you can't just write C6 and P6. You would have to write it a different way. Well, we have to write down what the multiplication was when we were doing the compound. So we saw that to get 6, we need to multiply calcium by 3. So let's write calcium and then 3. And then let's write down what phosphorus has to be multiplied by. Well, phosphorus has to be multiplied by 2. So let's write down 2. And now we have a ionic compound with a net charge of 0, showing that there's a strong force of attraction between the elements. I'm going to wrap up this video at this point. I hope you guys have understood ionic compounds, why ionic compounds form, and the different parts of ionic compounds. I've hoped you guys enjoyed, and Professor Anwell will now be leaving. Thank you.